Welcome back students, I am Sudipto Karmakar, Assistant Professor of Physics, SVIST, and in today's class we are going to solve a question that is from vector. The question came in the year 2022-23 even semester in MAKAUT, and the question is, show that the vector field that is given by A vector equals to 2x plus 3y square I cap plus y minus 3z square j cap plus x square plus y square minus 3z k cap has neither source nor sink. So we have to solve this problem. So let's start. Now, in case of vector, what do you mean by source field or sink field? So if we take divergence over any vector field, let the vector field is A. If this divergence is a positive quantity, that is it is a positive quantity, that means it is greater than 0, that is positive. So it gives us source field. If the divergence of any vector is less than 0, that is negative, then it represents the A vector is a sink field. And if the divergence of any vector it is equals to 0, that is not positive or negative, it is simply 0. So it represents A vector is a solenoidal vector field. In the given question, it is said that we have to show that A vector has neither source nor sink. That means we have to show that the divergence taken over this given vector field A, it is simply equals to 0. That means it is neither source nor sink. So we just simply have to take divergence over this given vector, and we have to show that it leads to 0 result. So let's start. So the A vector is given by 2x plus 3y square. This is the x component, this is the y component, and this is the z component. Okay. So we have to take divergence over this vector. So what is the divergence? Divergence, that means divergence of A vector, that is equals to I cap del del x. Sorry. I cap del del x plus j cap del del y plus k cap del del z dot the given vector, that is two x plus 3y square I cap, that is I cap 2x plus 3y square plus j cap y minus 3z square plus k cap x square plus y square minus 3z. Okay. Now we have to solve this divergence. As we all know that in case of dot product, I cap dot I cap, that results 1, j cap dot j cap, that results 1, k cap dot k cap, that also results 1. And we also know that I cap dot j cap equals to 0, j cap dot k cap, this is also equals to 0, and also k cap dot I cap is results 0. So we have to remember these relations. Now, if we multiply this I cap term with I cap, j cap and k cap, so I cap dot I cap, that results 1, I cap dot j cap, that results 0, I cap dot k cap, that results also 0. So as a net result, we just have a single term, that is I cap dot I cap. That means del del x, it is going to operate on the I cap component of the given vector field. So we have del del x that is going to act on the I cap component, that is 2x plus 3y square. Plus, similarly, j cap, when it is multiplied with I cap, that results 0. When j cap it multiplied with j cap, that results 1. And j cap when multiplied with k cap, that also results 0. So as a result, we only have a single term, that is del del y, that is going to act on the j cap component. Plus, similarly, if we take a look in the k cap component, so when it is multiplied with I cap or j cap term, that results simply 0. Only one term that survives when we multiply k cap with k cap. So it results del del z, that is going to act on the k cap component of the given vector field. Okay, so there are three partial derivatives that is going to act on three terms. Take a look on the first term. Here we have a partial derivative with respect to x that is going to act on 2x plus 3z square. 2x plus 3y square. So, since we have a partial derivative, so apart from x, all the terms will be taken as constant. Only those terms which contains x will be non-zero. So we have del del x that is going to act on 2x, that results 2 into 1. Okay. Plus, when we act or when we operate del del x on the term 3y square, it simply becomes 0. Plus, what about the second term? We have partial derivative with respect to y, and within this bracket we have y minus 3z squared. As we all know that we are taking here partial derivative. So apart from y, all the other quantities like x and z are taken to be constant. So only this term will survive. That means we have here 1 minus 3z squared. There is no y, so it simply becomes 0. Plus here we have del del z that is going to act on x squared plus y squared minus 3z. So these two terms, x squared and y squared, these two terms will be taken as constant since we are taking partial derivative with respect to z. So as a result, we have the first term becomes 0, the second term becomes 0, and the third term becomes, we have minus 3z, so it simply becomes 3. So if we simplify this, we have 2 plus 1 and there minus 3. So that results 0. So we have our divergence taken over the vector field A. The divergence taken over the vector field A that leads to 0. So it implies that A vector has neither source nor sink. Since it is simply 0, no positive, no negative, simply 0. So that implies that A vector has neither source nor sink. That means, that is, A vector is a solenoidal vector field. So here we have shown that A vector has no source or sink field. It is simply a solenoidal field. Thanks for watching. See you in the next video.